In this tutorial, transient CFD analysis of rotor stator domain using Ansys CFX shall be demonstrated. Transient CFD analysis using time transformation method shall be demonstrated in this tutorial. Let us open a steady-state CFX file. Steady-state results of a single sector models are already generated for this purpose. Check the link mentioned in the description below for tutorials on steady-state analysis. Let us open the steady-state CFX file and save the case file as transient time transformation model. Now let us change the analysis type to transient blade row model. Check for the number of components specified in both rotor and stator domains. Change the interface to transient rotor stator interface. We shall now look at the basics of transient blade row models. Transient blade row models are categorized into profile transformation, time transformation and Fourier transformation models. We shall be discussing profile transformation and time transformation models in this tutorial. Profile transformation model. This model is mainly used for transient rotor stator frame change analysis. This model results in same solution as conventional transient analysis model with transient rotor stator interface. The flow profile of upstream domain outlet will be scaled and provided as input into downstream domain inlet region, hence it is important to have pitch ratio close to 1 between both domains. For this purpose, we need to model multiple domains to meet pitch ratio close to 1. For example, in this single domain rotor stator case the pitch ratio is 1.27. There are 36 rotor blades and 46 stator blades. Hence sector angle is 10 degrees for rotor and 7.82 degrees for stator domain. This results in pitch ratio 1.27. To make the pitch ratio close to 1, we need to model multiple domains of rotor and stator. In this case, let us model 3 rotor domains and 4 stator domains. This results in sector angle 30 degrees for rotor and 31.28 degrees for stator, and the pitch ratio is close to 1. Next is time transformation model. This model is mainly used for transient rotor stator frame change analysis and it is valid only for compressible flows. This model can also be used for transient inlet disturbance case. Single sector periodic domain can be used for both rotor and stator, but pitch ratio should not deviate much from unity. Pitch ratio should fall within certain range given by this expression. Here, m omega is the Mach number associated with rotor rotational speed, m theta is Mach number associated with flow tangential velocity, and next is the ratio of stator domain pitch to rotor domain pitch. For most applications m omega is in the range of 0.3 to 0.6. This allows the pitch ratio to be in the range of 0.6 to 1.5. For more details, refer to Ansys CFX help manual. Let us go to Transient Blade Roll Model and choose Time Transformation Model. We can see the passing period calculated automatically here along with time steps. Let us see the calculation behind this. There are 36 blades in rotor, and sector passage time shall be calculated by dividing the time period for one revolution by 36. Next important step is to select the flow parameters to save in each time step for this transient model. Let us change the maximum coefficient loops to 5 and solve a control. We shall save the transient case file and definition file. Now let us open the time step selector and evaluate results at each time step. We can save the video using the Save Movie option. Click play button for quick animation and for saving the video. We can plot other parameters and check the results for each time step. We can see the blade rotation for full 360-degree passage. Thanks for watching. Kindly comment and subscribe.